Okay, so a dilation is either a increase or decrease of the size of a thing. And uh, if it's dilating around the origin, the math of it is pretty easy. Watch what we do here. See how this says a fourth? I'm going to take the original points. Do that. God dang it. There we go. So K is the point 1, 2, right? 1, 2. I'm going to take each of these coordinates and multiply it by a fourth. 1 times a fourth. Oops, I wrote a half, but I meant to write a fourth. 1 times a fourth is equal to 1/4, right? So K prime, the x part, is 1/4. If I go 2 times a fourth, that's 2 over 4, that's 1/2. I'm going to take, let's see, J's coordinates are 3, -1, 3, -1. So I'm going to take 3 times a fourth. That makes 3/4. And -1 times a fourth. That makes -1/4. -1/4. And then I'll do L. L is -2, 0. -2 times a fourth. So remind us how to do, when we're multiplying a whole number by a fraction, there's an invisible over 1 that happens here, and then I multiply across. -2 times 1, -2. 1 times 4, 4. Oops, I forgot that. Yeah, I do have the negative. Okay. -2 over 4 is the same as -1/2. So that's -1/2. And of course, 0 times a fourth is 0. So -1/2, 0. That's all I had to do, is multiply them by fractions. Now, let me show you how you could do this with decimals instead of fractions if the fractions are freaking you out. Let's do it with decimals instead. We're going to get the same kind of numbers. Now, to turn a fraction into a decimal, I just go, see how this is 1 over 4? That's the same as 1 divided by 4. Top to bottom, 1 divided by 4, that's 0.25. So I can just take each number and multiply times 0.25. If I take 1 and multiply it times 0.25, I get 0.25, right? So this number right here is 0.25. Let me just write that. So this could be 0.25 instead of 1/4. 2 times 0.25. 2 times 0.25 is 0.5, right? Because 2/4 is 50 cents. So you can do them as decimals too. I don't care. Either of those are fine with me.